Assalamu alaikum. First, I'd like to thank respected session chair Professor Mustafa and co-chair Dr. Ahmed for giving me this wonderful opportunity. Without delay, I'm starting directly. I'm MD Tawfiqul Haqqan Tushar. Today I'm here to present our research article titled Detecting Chronic Kidney Disease at the Initial Stage, a novel hybrid feature selection method and robust data preparation pipeline for different machine learning techniques. The co-authors of this paper are MD Tawhidul Islam and Fazul Islam Raju. Without their meaningful contribution, this research would not have been completed. The structure of our presentation is as follows. First thing first, problem statement. Chronic kidney disease has infected almost 800 million people around the world. Around 1.7 million people die each year because of it. Detecting CKD in the initial stage is essential for saving millions of lives. Many researchers have applied distinct machine learning methods to detect CKD at an early stage, but several necessary data processing steps are still missing, which decreases the ML model's efficiency, effectiveness, and robustness. Besides, most of the researchers used one or two feature selection techniques, but there is a minor correlation among the features, so it is not an effective way to select the important features by using only one or two techniques. Introduction. We present a structured and thorough method for dealing with the complexities of medical data with optimal performance. In our research, we applied KNN imputation to impute missing values, local outlier factor to remove outliers, SMOTE to handle data imbalance, K-stratified K-fold Cross-validation to validate the ML models, and a novel hybrid feature selection method to remove redundant features. Applied algorithms are SVM, Gaussian Naive Bayes, decision tree, random forest, logistic regression, KNN, GBoost, AdaBoost, and XGBoost. Finally, the random forest can detect CKD with 100% accuracy without any data leakage. Here are a few significant related works. The major contribution of the first paper is that the researchers have used 55 samples of real-time data along with the public dataset, but they have used only the chi-square test for feature selection, and they have applied mean-median imputation. Also, the AOC score is not available in their paper. The major contributions of the second work are they have used KNN imputation to fill in the missing values, and an integrated model has been established that combines logistic regression and random forest by using perceptron. But the necessary data preprocessing steps are missing and the AOC score is not available. Here in the third related work, the authors have implemented multiple feature selection methods and extracted the 11 most important features, but they have also used the mean median imputation, which is not suitable for medical data. Several data preprocessing steps are not available. Also, the AOC score is not given. The main objective of this research is to detect CKD at the initial stage with 100% accuracy and AOC. We have developed and proposed a robust data preparation pipeline and a novel hybrid feature selection method to achieve the research goal. Here are the subsections of our methodology, and it's the workflow diagram. Now, preliminaries. The preliminaries to building the models are specified in this subsection, which describes the dataset and the working environment. Data collection and cleaning. We have collected an imbalanced and binary class dataset named Chronic Kidney Disease dataset from the UCI Machine Learning repository. The dataset has 400 samples and 24 features, where 250 belongs to CKD and 150 belongs to not CKD. The features packed cell volume, red blood cell count, and white blood cell count were mistakenly considered as nominal because of typing errors. We have converted those features into numerical data types. Similarly, a few other features also have some typos which has been fixed by the Python map method. Experimental setup. We have performed all the techniques in Python using Google Colab, including packages or modules, scikit-learn, NumPy, pandas, etc. Data partitioning. We have followed the cross-validation and testing approach for data partitioning, where 75% of data has been separated for the training set and 25% of the and 25% for the testing set. Data preparation. We have fitted data preparation techniques based on the training set, then applied transformation on both training and testing sets. I am briefly describing the data preparation methods. Encoding. After cleaning the datasets, there were 10 categorical features. We have encoded the values of those categorical features into zeros or ones with one hot encoding technique. Table 1 shows which categorical values have been encoded into 1 or 0. Normalization. We have rescaled the features using the min-max scalar. It rescales features ranges between 0 and 1 using equation 1. Missing value imputation. The dataset contains 24 features and 400 records, where 1008 values are missing. To handle those missing values, we have used the KNN imputation technique. For medical data preprocessing, KNN imputation provides the most effective outcome compared to mean and median. Outliers. Outlier removing. Outliers can lead to training a model from irrelevant data. According to the dataset and problem statement of this research, we have implemented the local outlier factor technique and found around 26 samples containing outliers. Data imbalance handling. We know class imbalance affects the accuracy of machine learning models because the machine learning models provide poor accuracy towards the lesser number of data class. Here we applied SMOTE technique to handle imbalanced data. Table 2 shows the frequency of the CKD in various steps of data preparation. Feature selection. We propose and apply a novel hybrid feature selection method which aggregates the wrapper, filter, and ensemble feature selection techniques. Here, chi-square test and mutual information have been applied from the wrapper method, recursive feature elimination with cross-validation, along with multiple estimators from the filter method, and used random forest and decision tree classifier from the ensemble methods. The approach eliminates the redundant features and imparts three subsets F1, F2, and F3 using equation 2, 3, and 4 respectively. And these equations are derived from the set operations below. To reduce redundancy, identifying correlative features is also important. We conduct the Pearson correlation check and find only 7 features have over 70% correlation. Figure 2 depicts the correlation among features, and table 2 shows the correlative features which have over 70% correlation. We have only considered those features which have over 85% correlation. Finally, the hybrid feature selection techniques imparts three subsets F1, F2, and F3, which include 13, 8, and 5 features respectively. Standardization. Standardization has a substantial impact on the machine learning algorithm's performance. We standardize data using the standard scalar from the scikit-learn to ensure that all features are measured at the same level. Applying machine learning algorithms. The following machine learning algorithms has been applied to develop our machine learning models. Model validation. Validating the above models, we have used the repeated stratified K-fold cross-validation. It gives the original dataset's class ratio throughout the K-folds and repeats n times. Table 4 shows the mean accuracy of the models which are trained with different number of features found in equation 1, 2 and 3. Experimental results. We have used the accuracy, precision, recall, F1 score and AOC score matrices to assess model effectiveness. Table 5 shows the evaluation outcome of different ML models using feature set F1 found in equation 2. The F1 set contains 13 important features to train and evaluate the models. Here the random forest model provides 100% accuracy, F1 score and AOC respectively. Table 6 shows that the evaluation outcome of different machine learning models using feature set F2 found in equation 3. The F2 contains 8 important features. Here also random forest provides the highest performance. Table 3 shows the evaluation outcome. Table 7 shows the evaluation outcome using feature set F3 found in equation 4. The F3 set contains 5 important features. There the SVM, random forest, GBoost and XGBoost models provide the highest accuracy of 99%, but the SVM model performs best because of the highest AOC score. Table 8 shows the accuracy comparison among table 5 to 7, and we critically analyze the findings in figure 3. Considering figure 3 and table 8, we can decide that the ML models perform comparatively higher in terms of AOC score when trained using the feature set F1 and achieve a higher accuracy score when trained with feature set F2. Figure 4 illustrates the accuracy and AOC score of our finally selected models. From the perspective of the medical dataset, the AOC score is more meaningful compared to the accuracy score. So we ultimately select those ML models which are trained using the feature set F1. In table 9, we compare the accuracy of our method with some related works. The comparative study shows that the proposed method provides higher accuracy in detecting CKD at the initial stage than the previous works. Conclusion. In this research, we have dealt with the complexities of medical data and found an optimal solution for detecting CKD in its initial stage. Also developed a lighter machine learning model using only 13 important features, which may reduce the time and cost of diagnosis. Besides, our method outperforms existing approaches, achieving 100% accuracy. Future research direction. The research can be extended further by using the real-time dataset and adding the domain knowledge in detecting outliers, which will enhance the robustness of the proposed method. Here are the references from our work. Finally, our presentation has been completed. Now I would love to take questions from the audience. Thanks a lot for your time and cooperation. Assalamu alaikum.